Hello student, I welcome you in the lecture of fine structure of spin orbit and coupling. Okay. In this lecture you are going to understand what exactly fine structure is first in single electron atom and then in multi electron atom. Then for the formation of fine structure or the main cause of fine structure, what is the reason that is that is mainly interaction of spin and orbit angular momentum, so that you are going to understand what type of spin and orbital angular momentum in atomic system is responsible to give rise the fine structure in the atomic spectra. And for understanding of this, we will have to review on certain origin of interaction and effect of coupling between orbital and spin, and then on it on the spectral lines. So these 3 points expected that you are going to understand in the next two lectures. One is just taking a basic background about what spin in momentum, then orbital momentum, and what the results will come out when spin and orbital momentum are coupled together. Okay. So for the background review, I just show you one figure. This is the graphical correlations between wavelength versus count, and this is the wavelength emission spectra of one particular system. Now here in this graphical relation, why I am showing this graph, that you can easily see that here there is a splitting of spectral line. Actually there is a one spectral line, but it is get splitted into two, having the wavelength, one wavelength is 5889.96 angstrom and second one is 5895.93. So you can easily correlate that the difference between this is just a 6 angstrom, around 6 angstrom. Okay. And of the spectra, and this spectra is splitted if it is resolved properly. If we use the high resolution spectrometer, then it is possible to resolve the spectra. Otherwise if there is no high resolution, then it will be observed to be single line. But if we observe it by high resolution spectra, then it is observed to be splitted into two with a very closely separated wavelength. Okay, these are referred as the doublet of spectra, doublet spectra. Now, this graph is actually a sodium atom sodium spectra. This is the D line, which is splits into two lines. Mostly this splitting is observed in all type of system, not only single electron or double electron, all type of system. In hydrogen also, if we observe the system by a high resolution spectrometer, then we can observe the doublet in hydrogen spectra also. And this occur for all type of transition except x is equal to 0. Okay, only S is equal to 0 we are not observing, but in most of the atomic system, in multi-electron atomic system, this splitting is observed. But actually, why this splitting is originated? Okay. Because in earlier discussion, whatever spectra we have defined, alkali atom spectra, hydrogen atom spectra, helium atom spectra, that we have studied in detail. Okay, and the main cause of emission of spectra is the transition of atomic system from various energy level, and these energy of this energy level are decided by electron nucleus interaction, because while solving the Hamiltonian we consider that potential, and that potential leads to formation of different orbitals, and they have different energy levels, and that is decided by that potential. Okay, but for the splitting of spectra or for the doublet, this potential is not responsible, because if we solve the Hamiltonian by considering this potential, they are not giving anyway the reason for splitting of the spectra. Eh, we can't observe any type of outcome which show that there is a splitting of spectra takes place. Okay, so other than Coulomb interaction between the nucleus and electron, okay, there is another reason responsible for the splitting of spectra, and that main cause is the spin orbital interaction. Okay, that that spin orbital interaction will leads to fine structure of spectra. Okay, these are called the fine structure of spectra. In multi-atomic system, not only a single atomic system or alkali system, in multi-electron system, we can also observe such a spectra, and this is known as fine spectra. Okay. Now we try to understand the origin of this fine spectra. What is the origin of this fine spectra? Because if the Coulomb interaction between the nucleus and electron is not responsible, then what is the reason? Okay. Now I again go to our background. I am refreshing your background idea which we have discussed earlier. Okay. For the explanation of spectra, we have used the Hamiltonian, and we try to solve the Hamiltonian. The equation, general equation of Schrodinger equation for solving the energy states of the atoms, so that are responsible for the emission of spectra, we use this equation. Okay, this Schrodinger equation. Now, in case of multi-electron system, we split this Schrodinger Hamiltonian as H star plus H1 according to the central field approximation. H star is the non-spherical part and H1 is the spherical part, or vice versa. Okay, where H star is considered to be this. I am not much going to detail of this because already we have discussed, where U potential we consider as this average value, or H1 non-spherical part we consider like this. Okay, and we have solved the Hamiltonian, and then we try to explain the various type of spectra which we observed in case of alkali, helium and hydrogen atom, and this can be extended for other complex systems also. Okay, and here solely we consider that either electron nucleus interaction or electron electron interaction are responsible for origin of spectra. But whatever the splitting or doublet we are observing here, that splitting or doublet, okay, we can't explain by using this. We can't observe that splitting in this description. Okay, and due to that we have to consider some another consequences for the doublet, and that is spin orbit coupling. That we need to include the spin orbit coupling into the Hamiltonian if we want to solve the Hamiltonian to understand the splitting of spectra. Okay. Now I go just explain you briefly about what spin interaction, what orbital interaction, okay, what is their effect in the presence of magnetic field, which of course generated intrinsic magnetic field generated by orbital motion of electron or spin motion of electron, and if anyway external magnetic field is exist due to the nuclear forces or other some external forces, then what will be the change in that orbital motion, what will be the change in the spin motion. Okay, that whatever idea I am going to present in this 3-4 transparency, that just a review, because already you have studied it. I just refreshing your memories about this. Okay, now you observe the figure which I have shown here. What this figure indicate? This figure indicate that the electron is revolving in certain orbit. Okay, now you know electron have a charge, and when it is moving, it is just act as a current loop. And as the electron orbital motion surrounding the nucleus is act as a current loop, therefore magnetic field is generated. Okay, that is referred as the intrinsic magnetic field, and this intrinsic magnetic field influenced on, of course, on orbital as well as spin motion of electron. Okay, so in some standard language we can say that when electron is revolving in the Bohr orbits, according to Bohr atom model, when electron revolving in the Bohr orbit, it is a non-radiating orbit. Okay, to explain the stabilization of atomic system, they have considered as when the electron is revolving in Bohr orbit, this Bohr orbit are non-radiating orbit. Okay, and so it is act as a current loop, whatever I have explained, therefore it generates the magnetic. And according to the thumb's left hand rule, if the magnetic field current is flowing along this direction, magnetic field is acting along z direction. Okay, this is the concept. So what is the magnetic moment associated with magnetic field? The magnetic moment is the unit to count the magnetic field, which is measured as the mu L is equal to I into A. Okay. So this I into what is I? I referred as 1 minute. I will select my pointer. Okay, huh? I into A. Where what is the I is? I is the current of this current loop, which is constituted by electron, and A is the cross section area. Okay, where the current is, E minus E omega by twice pi. What is omega? Omega is the angular velocity. Okay, and what is A? A is the cross section area, which is of the loop. If R is, we consider radius because this path have a radius R. Okay, and if we R is considered as radius, that cross section area of the circle elliptical path is pi r square. Okay, now substituting this value, we get 1 by 2 e omega r square. Okay, so mu L, magnetic moment associated with the magnetic field, which is generated by current loop. The magnetic field which is generated by this current loop, okay, current carrying electron while moving, completing its orbital path, because first we consider orbital magnetic dipole. That value, that magnetic moment is minus 1 by 2 e omega r square. Okay, everybody have cleared now what I say? When the electron is revolving surrounding the nucleus, as the electron are charged particle, its motion is related to magnetic field. Therefore, if the electrons is revolving in the xy plane, the magnetic field is generated in z direction. Okay, that leads to magnetic moment, and the value of the magnetic moment is taken to be minus 1 by 2 e omega r square, where omega is angular velocity and r is radius. Now, due to this magnetic field, what will be the change in the magnetic orbital quantum momentum? The actually orbital angular momentum is counted by or it is denoted by letter L, where L is equal to MEVR. Okay, magnetic quantum number L, orbital quantum number L, not magnetic, sorry, orbital quantum number or orbital angular momentum. This orbital angular momentum is mvr, general formula. V is velocity, linear velocity, r is the radius, and m is the mass, mvr. This is orbital angular momentum. You know very well. Now this v is linear momentum, and what is the relation between v and omega, angular momentum? V is equal to r omega. So when we substitute V is equal to R omega, what we get? There should be E, ME, ME omega R square. Got it? So it is the orbital angular momentum. Okay. Now, as mu L, magnetic moment, is 1 by 2 E omega square R square. Therefore, here, if we replace omega R square by L by ME, here we can replace, sorry, my pointer, oh sorry, we can replace omega r square by L by M. This omega r square, I can, if I bring ME here on this side, it become L by M. So what will be remain? Mu L is equal to minus E twice M L. Okay, that will be the magnetic momentum, okay, due to orbital motion, and it's closely related with orbital angular momentum. Okay, magnetic momentum is closely related with orbital angular moment. Okay, it means the magnetic moment affect on the orbital angular quantum number. Okay, so now simple mathematical step we are using. Okay, that Bohr, this is the Bohr magneton. Bohr magneton is taken to be E twice m h, which is constant. It's related to magnetic moment of first orbit. Okay, this is related to magnetic moment of first orbit. It is 9 point standard value 9.27 into 10 to the power minus 24. So orbital magnetic moment in term of Bohr, if I substitute this value in orbital magnetic moment, which we have studied, mu L is equal to E by twice m minus E by 1 by 2 E by twice m L. If I substitute E by twice m by mu B by H, okay, I bring H here, it is mu by H is equal to E by twice m. So I substitute E by twice m in this formula mu by m. Okay, our earlier formula. GL, it is just a Landau's orbital factor, okay, which is used to count the degeneracy. Here del L is GL is equal to consider to be 1 for degeneracy. So we get mu L is equal to minus mu B H cross L. Okay, this is simple replacement by Bohr's magneton. We are Bohr's magneton have substandard. It is related to magnetic moment of first orbit, Bohr's orbit. Okay. Now, as the L is revolving under the influence of magnetic field, which is generated by orbital motion of electron. Therefore, L is again get affected, and that L vector we taken to be L vector is equal to L plus 1 H. So when we substitute L, replace the L by square root of L plus 1 H cross, we get mu B L H cross, because H's get cancelled. If we substitute there, this value is cancelled here, and what will be remain? Mu B square root of L plus 1. Okay. So along Z direction, now because now the magnetic field is also acting along Z direction, so in Z direction the orbital quantum number, this is the orbital quantum number, this is the magnetic momentum, this is the magnetic moment along orbital direction. Okay. Now magnetic moment along Z direction, the orbital magnetic quantum number we can taken as mu L H cross. ML Lz is equal to ML H cross. Okay. Now substitute, therefore mu magnetic momentum due along Z direction, that will be taken as mu B by H cross Lz. In this value mu Lz, because this is mu L, this is the direction, magnetic moment direction, okay, along orbital. This is the magnetic moment along Z direction. In place of L we can write Lz. Okay, and Lz is equal to ML H cross, and therefore minus mu B ML. This is the magnetic moment devoted to Z direction. This is magnetic moment, okay, originated due to orbital motion in any direction of L. It is L direction. It is Z direction. Okay. Now, how, because whatever earlier effect we have studied, this is intrinsic magnetic effect, because whatever magnetic field generated due to orbital motion. Now we will see how, if we applied the external magnetic field, then how the orbital magnetic dipole moment is get changed. Okay, intrinsic में तो we have seen. Now if we apply extrinsic field, what is its effect? Okay, when we place the dipole moment in external magnetic field along the z direction. Now here the magnetic field is acting along z direction. Okay, intrinsic also acting along z direction. So the torque is originated and the value of that torque is taken to be mu cross B, where what is B? B is the magnetic field induction, and what is mu? Mu is the magnetic moment, dipole moment, magnetic dipole. Okay, and due to this external magnetic field, this is the external magnetic field. Due to the external magnetic field, there is a change in energy. Due to external magnetic field, there is causes the change in energy. And how much that change in energy? That change in energy is the change in momentum dot product with change in magnetic induction. Change in momentum and change in magnetic dot of magnetic induction. When B is applied, then whatever the change in dipole moment, okay, along the field direction, that will leads to change in energy. So there are now the torque will play, which is generated due to the applied magnetic field. Torque which is generated due to applied magnetic field. Okay, it's create two component. One component of torque is along the B की जो डायरेक्शन रहेगी वही डायरेक्शन में, so that it is parallel to B and it try to lowest energy of the configuration. And second effect of torque is it will act to change the angular moment, which is perpendicular, okay, to the magnetic field direction. Okay, so this change is perpendicular to angular momentum. ये जो change है, what is the direction of this change? This change is perpendicular. So torque का एक component जो parallel है, that will lowest the energy configuration. Another component is perpendicular, that will change the angular momentum, causing the magnetic moment to presses around the direction of magnetic field rather than settle down in the direction of magnetic. It is presses around the direction of magnetic field. This is direction of magnetic field and presses around the direction. Suppose the direction of magnetic field is taken to be Z, then in XY plane it presses around the direction of magnetic field. Okay, rather than settle down. In first case it is settled down, and in second case angular momentum का effect क्या है? In angular momentum there is a change in angular momentum which will cause the change in magnetic momentum, which is presses around the direction of magnetic field. Are you understand? So when we applied the external magnetic field, then angular moment is also get changed, which is perpendicular effect, and the magnetic moment also got changed, which is along the field direction. Okay, and this type of precession is called Larmor precession. If I give you the figure, this figure clearly show you. Okay, it's clear you about this. What the change this figure show? In this figure, if we focus, this is the L direction, this is the Z direction, BZ direction, okay, and due to this two effect, there is create the change in L. This is L. What is L? Orbital magnetic momentum. This orbital magnetic momentum is changed, and that change component L sin theta. L cos theta is along the field, L sin theta component. Okay. So when a torque is exerted perpendicular to the angular momentum L, it produces a change in angular momentum. Let that change be del L, which is created in time del t. Therefore, this torque we can taken as del L by del t. How much that del L? That del L is, how much the change in the del L? L sin theta into del phi. Have you understood this or any confusion? When we applied the beachhead, external magnetic field, then there is a theta angle change in the orbital momentum, angular momentum. Okay, and therefore that change is, suppose in linear direction we have taken del L, then what is del L? Del L is, what is del L? Earlier this direction, now this direction. Okay. Therefore del L is L sin theta into d by dt. Now d phi is angular or circular displacement. Okay, angular displacement and dt is time. Therefore, both ratio we can write as angular velocity. Angular displacement divided by angular time, that leads to angular velocity, and thus it is L omega sin theta. Torque acting here, force acting. Actually, what is torque? Torque is the force along circular direction. So force acting in this case, okay, when external magnetic field is applied, whatever force is acting, that is taken to be L omega sin theta. And as the torque is taken, earlier we considered mu cross B, therefore it is mu L B sin theta, mu B sin theta, or how, what is mu L? Mu L is we taken as, mu L is taken to be mu L is mu BL. Mu L is mu B. This is mu L. This mu L is mu BL and B sin theta. Okay. So mu B L B sin theta, or another what value is L omega sin theta. Mu B H cross L B sin theta, or torque L omega sin theta. Therefore, omega is equal to, we got, because this is also torque, this is also torque. So we correlate these two. After correlating with these two, we got omega is equal to mu. These are just a mathematical equation treatment, okay, for understanding this concept. This is Lymer frequency. This is called Lymer frequency. Okay. So what happen if we applied the external magnetic field? Then there is occur the Larmor precession. Okay, precession perpendicular to the direction of magnetic field, and the frequency or velocity is taken to be by this value. Okay. So what we understood, sorry, about the orbital motion, under the effect of magnetic field, either intrinsic or extrinsic, orbital angular momentum is getting changed. Same way, there is, in analogous to this, orbital spin quantum number or orbital spin momentum are also getting changed Okay, and that is written as mu s is equal to minus gs mu b by h plus same analogous. Okay, earlier mu b h cross l, now mu b h cross s, and along z direction gs mu b ms. Same thing is there. Only there mu gl we have considered, Landis factors we have considered. Okay, 1, and here gs mu b h s. Now how they are interacted? What? And orbital motion and spin, orbital angular momentum and spin angular momentum interact. Because what is our intention? Our intention is to understand their coupling and how that coupling affect on origin of hyperfine spectrum. So just we are revising first the concept of orbital angular momentum, spin angular momentum, and their effects. Effect of magnetic field on orbital angular momentum and spin angular momentum. Now, combined effect of magnetic field on orbital and spin angular momentum and simultaneously magnetic moment. Let us consider the magnetic interaction between orbital magnetic moment and intrinsic spin magnetic moment. This is known as spin-orbit interaction. Let us understand how this interaction occurs or takes place. Okay, so I think you have very well cleared how the orbital angular momentum is developed and respective change, how orbital magnetic moment are developed, how spin magnetic moment are developed. Okay, now next one is, okay, to understand the interaction. So for that interaction, we consider two conditions. First condition is that we have considered that frame of reference of electron, and in that frame of reference of electron, nucleus is moving. Just a virtual understanding to understand this interaction. What is our first assumption? It is a frame of reference of electron, and in that frame of reference of electron, nucleus is moving about the electron. Okay, when nucleus is moving, then current which is flowing due to the motion of nucleus surrounding the electron, that will be taken as ZeV, where Z is the atomic number, E is charge of nucleus, of course, and V is the velocity. Now according to Ampere law, when the charge is moving, because nucleus also a charged particle, its magnetic field induction or magnetic field is taken to be mu 0 4 pi J into R by R cube. Now substituting J, we get Z E mu 0 by 4 pi V into R by R cube. And now as L orbital quantum number or orbital uh, magnetic angular momentum, L is equal to R into M. Okay, or I can change the sign, minus mv into r. Just I am changing the sign. Okay, their position. So change the sign. Therefore, after substituting v into r as L by M, because this m if I can bring on this side, then v cross r is equal to L by M. As v cross I is equal to L by M, therefore this we get B is equal to Z E mu 0 by 4 pi mv cross r cube, or mv by cross r cube is L by r cube minus. If we take an average field will be like this. 1 by r cube is average. Everybody have cleared? Very simple concept. Just for convenience, for explanation, it is considered that the electron is a frame of reference, and with respect to electron, the nucleus is moving. Okay, because that calculation is little bit easy in case of nucleus as compared to electron considering motion. Maybe due to that they have considered this concept. Otherwise, there is just this is the assumption. So, by considering this assumption, the magnetic field at electron due to nucleus, because nucleus is moving, that will be taken to be B is equal to mu 0 4 pi G cross R into R cube, where J is equal to Z in B. So substituting this, we got the magnetic field generated by the magnetic field due to the motion of nucleus is taken to be this. Okay. Now, the spin orbit, due to this, the spin orbit interaction energy, okay, the orientation of potential energy of magnetic dipole moment del E spin orbit is mu s into B, where B is magnetic field generated by considering nucleus moving around with respect to constant electron. Where what is mu s? Mu s is GB by H, mu B by H cross S. So substituting this value, we get change in the potential energy, orientation potential energy due to magnetic dipole moment. It's a very important. Due to the magnetic dipole moment, whatever the change is there, that change is, this is one of the important. Due to magnetic field, change in energy, that change in energy is count like this. Okay, what is that? The magnetic spin magnetic quantum number or spin magnetic momentum dot magnetic induction. What this magnetic induction? It is the induction of magnetic field generated by moving nucleus with reference to electron. Everybody got it? So change in energy due to spin and orbit, it is taken to be this. Then taken, if we solids in oppositely, means there is a reference frame of nucleus and electron is moving. So by Thomson precession, this del change, del E is taken to be 1 by 2 factor is getting 1 by 2 Gs mu B S H cross S dot. Okay. And this is the spin orbit interaction energy. This energy is spin orbit interaction energy, where after substituting B there, we will get, if we substitute B, then we will get this value S dot L, because in B there is a L. Okay. So how we understand this equation? This equation tells us that when in orbital motion electron are moving, then magnetic field is taken to be by this relation, and that motion will change the energy, and that change in energy will lead to this value minus mu s b. Okay, so the del SO is by, we can express by this relation, and we substitute B here by using this expression, then we get the B value into S into L. Means it involved the orbital angular momentum it involved an orbital angular momentum as well as it involved the spin angular. Both angular momentum is involved that indicate the interaction. So change in the energy due to the involvement of spin magnetic moment, angular momentum and linear angular momentum. If I replace this is a constant by SO, then I get this. So everybody have cleared up to this? This is just a revision of concept where del ESO leads to change in energy when under the intrinsic magnetic field or extrinsic magnetic field, the spin motion and orbital motion are influenced. Due to the influence of this motion, whatever the change in energy, that is counted by using this expression. So I think I should here. Okay, and I will send you few questions after hearing my this lecture. Okay, you just try to solve the question. Thank you very much.